Okay, this is a video to go over section 2.5, which is solving radical equations algebraically. So in the previous lesson, we solved equations graphically, and today we're going to be not using graphs, we're going to be using algebra and opposite operations to solve for the value of variable. Okay, so before we get into the radical equations, I just want to remind you of some strategies we use when we solve algebraically. So let's say we had an equation like this. We have 17x equals 13x plus 32. So the first thing you want to do when you're solving an equation is typically you want to isolate all of the terms with the variable onto one side of the equation. And you can do that by adding or subtracting those terms and moving them to the other side. So in this case here, I want to bring these, this term here, the 13x, to the left-hand side and join it up with the 17x. So because it's positive 13x, if I subtract 13x, that's going to remove it from the right-hand side since 13x minus 13x is 0. And in algebra, if you do one thing to one side of an equal sign, you have to do it to the other. So what that will do is it will cancel it out over there. And since these are like terms, I can put them together. So 17x minus 13x is 4x. You want to do this as a first step because it makes the equation a lot simpler and it combines, the goal here is to solve for x. So if we only have one x in the equation, it's a lot easier to solve for than if we have multiple. Okay, and then what you want to do is solve by using opposite operations to isolate x. If there's multiple operations to do, you want to do the opposite of BEDMAS order. So for example, if there was like an addition and a division to do, you would want to do the addition first and then the division. So opposite of BEDMAS order. In this case, we just have one operation happening to the x. The x is being multiplied by a 4. So the opposite operation to multiplication is division. So what we'd want to do to both sides is divide by 4. I like to indicate division by making a fraction instead of using a divide sign. So I'm going to do that here. I just simply go divide by 4. Fractions are dividing, means the same thing. So there we got the x or the 4's canceled out. We just simply would have x. And then on the right-hand side, 32 divided by 4 is 8. And we'd have our solution. So we are going to be dealing with equations today. They're going to be slightly more challenging than these ones because our equations are going to have square roots in them. And so we're going to learn how to deal with equations involving square roots and how to solve that. Okay, let's go to the first example here. Check your understanding number 1. This will be on the 3rd page of the lesson there. And I will do both of these today. Okay, so let's look at A first. And I'll kind of show the work on the left-hand side, and I'll write some little instructions or tips in red on the right-hand side. Okay, so same idea here. What you want to do is isolate your x. So first thing that we see going on with the x here is it has a square root on it, but also that square root, the radical, is being multiplied by 4. So let's move the 4 over to the other side to just simplify things a little bit. So the opposite of multiplying by 4 is dividing by 4. So when you have a radical equation, what you want to do is, if you can, isolate the radical, the square root, onto one side, or on one. Okay, so we'll do that as our first step in the next question as well. So I'm going to leave 3 over 4 as a fraction. You could write it as 0.75, but this is going to be easier to evaluate in the end if I just leave it as 3 over 4, and then I have square root x here. Okay, and now we need to do an opposite operation to remove that square root to solve for x. The opposite of square rooting something is squaring. Squaring and square rooting are opposite operations. I'll write that here. And square roots are opposite operations. They undo each other. So if I take the square of a square root, it's going to cancel it out. And so if I do something in algebra to one side of the equation, I have to do it to the other. And so on the right-hand side here, I'll just have x. And on the left-hand side, 3 squared is 9, 4 squared is 16. So I have 9 over 16. You can verify by plugging in that value and double checking that the left-hand side and right-hand side are equal. I won't do that here. Okay, let's go for a slightly harder one. We're going to follow these exact same steps, but there's going to be a few more sub-steps in between. So for part B, the equation looks like this. I'm going to rewrite it to scroll up here so I can see it. X plus 1 minus 7. So we said before we want to isolate the radical on one side. Same exact step here. Isolate the radical. So I'm going to work on removing the -7, the -7, and the 2. So when we want to go the opposite of BEDMAS order. So I'm going to remove the 7 first. I'm going to add 7 to both sides. So then I'll have 20 on this side, and then we'll be canceled out on the right-hand side. Okay, and then I'm going to remove the 2. The 2 is being multiplied with the radical, so the opposite operation to that is dividing. It gets canceled out. So I'll have 10 on the left-hand side, and simply my square root on the right-hand side. Okay, so I've isolated my radical term. That's done, and now I want to do the opposite operation to get rid of that square root. So I'm just going to remind myself that x squared and square roots are opposites. So I want to square both sides. Squaring will cancel out the square root. Oops, not 1,000, 100. 10 squared is 100. And squaring the square root, it'll get rid of it. It'll cancel it out. So I'll just simply have x plus 1. We have one final step to do here because it wasn't simply just x under the radical this time. So I'm going to have to subtract 1 from both sides here, and I'll have 99 equals x, or x equals 99. That's my final answer. We always want to box in our final answer when we're doing algebra. The other thing you want to do is write, if you can, if there's space, one step underneath each one. And what I like to say to students is try and just have one equal sign per line. So you don't need an equal sign in front of your expressions here. You just want to have the one equal sign that's in the equation stay consistent. So one equal sign per line, one step underneath the next one. And that's it. So the last thing we're going to do is just talk about this one last thing here. Not all radical equations have real roots. What that means, and then I haven't talked about this word here yet either, a root. A root to an equation is a solution. It's another way of saying solution. So if you see that word in your assignment, what is the root? It's just asking for what is the x value that makes this equation true? What is the solution? So it says not all radical equations have real solutions. What does it mean by that? So let's say we're trying to solve this equation here. Okay. What we would do first is isolate the radical. So we would subtract 5 from both sides. And we're going to follow their solution here. So we would subtract 5, and we'd end up with this right here. Square root of 2x minus 1 equals -3. Now just think to yourself for a second. The book goes on to solve further, but just think to yourself for a second. Why might this not have an answer? Can a square root equal to a negative number? Okay, so then what we do is square both sides, and we end up with the next line, 2x minus 1 equals 9, so we square both sides, and then we add 1, and then we divide by 2. So it looks like we have an answer. This looks like the solution. But if we plug it back in and try and solve, it doesn't work. If you plug it back into the left-hand side like they do here, you'll actually get 8, but then the right-hand side is supposed to be 2. The reason this doesn't work is because of this problem right here, this line right here. You can't have the square root of a negative equaling a negative number. A square root cannot equal a negative. So if you ever see an equation that equals a negative number, a square root that equals a negative number, you automatically know, actually, this has a fake solution. It's not a real solution. X equals 5 is not the solution to this equation. And this equation has no answers. There's no real roots, is what we say. There's no solution. What we call this, it has a special name. X equals 5 is called an extraneous root. You have to remember to look for extraneous roots when you're doing radical equations because they do pop up. And if you are just blindly solving and not really thinking critically as you're solving, you won't catch that the square root is a negative and you'll see that that's solution. That's another, also important to verify your answer, because when you verify, you'll realize something is wrong. It doesn't look right. So these pop up when you have radical equations and you should be aware of them. And that's all I'm going to do in the lesson today. So I'll just stop the recording.